In VXLAN, whenever unknown unicast traffic, what is unknown unicast traffic? A traffic whose destination is unknown to the leaf. What will switch do? Normal switch, I'm asking. What will normal switch do? It will flood. The same way, when a broadcast packet, for example, there is an ARP packet. ARP is a layer 2 broadcast. Even for ARP broadcast packet, the switch will flood. Normal switch I'm talking about. And also the multicast. When a multicast traffic comes, switch will flood. Usually the layer 2 switches will flood traffic of this BUM, broadcast, unknown unicast, and multicast. But flooding to all VLAN, no. Flooding to all the members of same VLAN. I'm talking about simple switching. I'm not talking about VXLAN. In a simple switch, flooding happens within the broadcast domain. Do you agree? Within that VLAN member, within that VLAN. Now, how do we achieve that in VXLAN? In VXLAN, there may be many tenants. Tenant is like, you can assume like a VLAN member. One VLAN member should not receive the bump traffic of other VLAN, correct? Likewise, bump traffic of one tenant should not go to other tenant. This can be controlled using a multicast address. You give one multicast address for each tenant and send bump traffic to that multicast address. So member of that multicast group alone will be able to receive that broadcast flooding, bump traffic, flooding. The flooding will be within that multicast domain. They only will receive the flooding. Yeah. Whoever is the tenant of that particular multicast will receive that bump traffic, will receive that flooding. Now, how many copies, if let's say in that tenant there are 100 people, will the packet sent to 100 different IP address? No. It is going to be sent to one multicast address. That is what I'm saying. Within VXLAN domain only we are talking. You are talking outside VXLAN only, you will have a lot of VLANs. Within VXLAN domain, there is no VLAN consideration. It is only the multicast address and VNIs. So now you may have many VNIs mapped to same multicast. So all the members of that VNI, all the members of all VNI who belong to same multicast will receive it. You understand? We call this as bridge domain. In ACI language, we call it as bridge domain. Even though they belong to different VLANs outside, they all belong to single tenant here. So advantage of multicast replication is you will be sending to one single address the bump traffic. It will go to all the members of that multicast group. Whereas Ingress replication is you will mention to whom to forward. The MPBGP EVPN control plane Why do we use this? To discover the endpoint so that you can exchange the host information between the leaf nodes. If you don't have MPBGP EVPN, then you will not be able to discover the endpoint to which you need to distribute the route information or host information. So you will need to always flood. But when we have a control plane, you will know whom to send, which leaf to send, which host is connected to which leaf. Because host in the leaf information is shared to the other leaf nodes, other leaves. So let us repeat again. The MPBGP EVPN control plane is used to discover the endpoints and exchange host information between the leaf nodes, IP multicast, or the Ingress replication is okay between the nodes. Now, IP multicast or Ingress replication is used for bump traffic. So for bump traffic, two options you have. You can use IP multicasting or Ingress replication. There are two ways to replicate bump traffic through the fabric, either one of many, one to many, or one to one many times. See, one to one is what? Ingress replication. Because you're going to say, to this guy you send it. Whereas here, one to many, you don't know how many. You just send it to a multicast address. So whenever we have one to many, it is good to use multicast. If you have few, then you use one to one. ARP requests are one example. ARP request is one of the example of broadcast, isn't it? That needs to be replicated using multicast group or Ingress replication. So Ingress replication can have scaling issue. Why you know? You need to mention everyone. Whereas here you just put one multicast address. See, Ingress replication can have scale issue as the switch need to replicate bump traffic to many times as VTP. If you have a 50 VTP, then to 50 VTP address that need to be duplicated. Same bump traffic need to be sent in 50 copies. See, let's read. Ingress replication can have scale issue as the switch needs to replicate bump packets as many times as there are VTP that own the VNI needing to see the traffic. As for example, with 50 VTP that own same VNI, 50 VTPs, member of same VNI, same VXLAN ID, requires bump traffic, replicate need perform 50 times. So you need to duplicate that one bump traffic 50 times, and you need to send to 50 VTAP address. Yeah, 50 IP address you need to put means you need to have 50 packets, isn't it? One packet, if you send using multicast, it will go to all 50. So bandwidth consumption is less. But if you duplicate 50 times for 50 IP address, then consumes lot of bandwidth in the network, isn't it? So in contrast to this Ingress replication, use IP multicast across the multi-pod environment, which is scalable, which can handle bump traffic as a fabric, natively propagate the capability of the required replication. So IP multicast replicate reduces the network load. You understand? That's it. That's all. That's all. If you are using Ingress replication, you are going to send to every VTAP address a separate copy. If you replace that with IP multicast replication, it will be more effective. See, MPBGP will discover the VTAPs. 50 VTAPs it has discovered. To that 50 VTAP, how are you going to send bump traffic? Are you going to send using multicast? then you are safe. You will not have much load. As a result, you will have an improved performance, and scalability also increases. Which one you choose, you decide. Okay, so BGP is a protocol to discover the VTAPs. If you say no, I don't want to have BGP, still you can use that one multicast only to always replicate, then it will be always flooding. That will not be called as the EVPN, that will be called as simply VXLAN. VXLAN without control plane will not need BGP. Only for control plane we use BGP. What is control plane here doing? It is discovering the VTAPs to whom the tunnel need to be established. So to those VTAPs, for the unicast traffic there is no problem, but for the multicast traffics and unknown unicast traffics and broadcast traffics, you need to focus on scalability, because bandwidth will be too much consumed if you have too many VTAPs. See, for a simple 4 leaves, you don't need increased replication. Sorry, you can go with increased replication. No problem. You don't need multicasting. But when you have more number, then scalability issue will start. That's the time where you need to go and configure IP multicast. So IP multicast, you need to enable spats mode, and then you need to configure RP on the spine. What is RP? Rendezvous point. So we configure anycast RP on the spine so that multicast group members and the multicast source can come together, and multicast will take care of your bump traffic. So that's a separate multicast topic. Have we finished multicasting? I don't think so. No. So we need to learn multicasting for understanding this anycast RP. Of course, I can show. I'll explain you how it works. You see, we are going to have spine, and we are going to have 3 leaves. Yeah. Now, you see, this has got a VTAP address. Let's say 1.1.1.1 and 2.2.2.2. Usually, we use the loopback interface address as the VTAP address. Nothing. You will associate this. Okay, I think you have not gone through the command line. That's the commands. That's why you are asking this question. I'll explain you those things with commands. Oh, this don't have any configuration at all. You see, please pay attention to this. This is creating tenant. For the tenant, this is the VNI. And this is for the VNI and related, like what to say. In this VNI, there will be some host connected, no? Down. Those host informations need to be carried, isn't it? Those things are imported. That is carried to other switch. And from other switch, it is also exported. Sorry, from other switch, it is imported to the from other switch, it is imported to other switch, it is exported. So for that, you need an ID. So you create something called route target, and you don't give an ID, you say simply auto. With VPN and without EVPN, you need to say. And this one, route distinguisher, for each tenant, you need a separate distinguisher to differentiate the control plane. So you need to give an ID. Usually we used to say 1:1, 2:2, something like that. But here you can say auto also in Nexus. This is not necessary. This is an optional one because you have already said auto. It will automatically generate. But here these people are using customized one. Next is under BGP, you enable EVPN like this. Okay, this is not needed. this is the one beta buttons. You understand now? Loopback code. So it uses this address to negotiate. Okay, and now okay, that's it. Now let me come back to the story. And we got some computers. We got brown and blue computers. Brown belong to one tenant, blue belong to another tenant. Now, let's say for blue, I am giving VNI 5555. That's the VNI of blue. And for the brown, I'm giving 66666. This is the VNI. Now this will be configured on all leaves. So this brown may be in VLAN 50. And this may be in VLAN 60. I take those 50 traffic, I put it into 6666, and I take this 50 traffic and I put it into 5555 traffic, 5555 VNI. I map it. And then we can use BGP, or you can use simple multicasting. If you want to simply use multicasting, both for unicast and BUM, then you can give like this 239.11111. For this 239.22222. You understand? two different multicast address. So it will always flood, always flood. To avoid this, what you can do, you can enable EVPN. So EVPN will form tunnel only between this. For blue, it will form tunnel, a blue tunnel. And for the brown, it will create another tunnel. Yeah. So there are two tunnels and already discovered. This tunnel endpoints are discovered through what? EVPN. So now there is no need for flooding all the time. Only when our packet comes, it will be a broadcast packet, isn't it? Now what this guy will do, because you have said multicast replication, it will use this multicast address and send the traffic. It will go only to these two guys, not to our brown guys, because brown guy belong to another multicast. From A, it will go only to B and C. It will not go to D, E, and F. Likewise, if D sends an R packet, it will go only to E and F. It won't go to A, B, and C. If you don't use that multicast, if you say I want Ingress replication, then what it will do, this leaf knows that I have two more leaves where blue is connected, isn't it? This leaf knows that I have two more leaf, one Mr. 4.4.4.4 and 5.5.5.5. VTAP address is, VTAP number is 5555, 55555, isn't it? So what it will do, it will duplicate that R packet into two copies. One to this address it will deliver here. One to this address it will deliver here. That is what Ingress replication. Two copies. You understood? In multicast replication, no two copies, only one copy. Same thing applies for unknown unicast and multicast. That's all, sir. Hmm. So your voice is breaking. Hello. Repeat, sir. Yeah, sure. Yeah, will be taken from the neighbor of EVPN. EVPN neighbors are the destination addresses. Yeah, and 5.5.5.5. Yes, both 444, 555. So when A sends the bump traffic, it will be forwarded to 44444 and 55555, which is the Ingress replication. All the information of host A will be forwarded to those two. If you want single copy to go to both instead of duplicating, then you may use multicast replication instead of Ingress replication. Correct. Very nice. That is layer 2 with VXLAN ID. Yes. Right. We'll